Hello friends, in our last video we have seen what is TLB and TLB testing. So moving forward, our today's topic is debugging features of architecture. The very first question is, what is debugging? As we all know, the debugging is the process of identifying and removing the errors or bugs from the hardware or software. This 80386 processor supports the debugging features. It provides some debug registers that we'll see later on. Now, this 80386 architecture features that supports the debugging are, first of all, debug status register. It supports the debugging feature. Next is your debug control registers. This 80386 provides 4 control registers ranging from CR0, CR1, CR2 and CR3. Next is your resume flag of E flag registers. Remember the diagram of E flag registers? These E flags are 32-bit registers. From that, the resume flag, it provides the debugging feature for the 80386. Next is, it allows task switch monitoring. Now what is task switch? When processor switches from one particular task to another task, that we called as task switching. Meanwhile, the status of every task is stored by the processor. For that purpose, we are using TSS. Next is trap bit of the TSS. Single step, that means trap flag. This is your single step flag. Now it allows the users to select the debug conditions related to the 80386 debug registers. There are total 8 debug registers from DR0 to DR7. It helps your debugger to determine the conditions that created the debug condition. It allows the user to monitor the program flow by indicating whether the 80386 should generate the debug exception along with the execution of the instruction. When an event that needs to be executed by the debugger, the processor invokes the task or procedure automatically. This is all about debugging features of the 80386. Now moving forward, our next topic is debug register. This debug registers are very important topic as your exam point of view. Now there are total 8 debug registers from DR0 to DR7. You can see here the structure of debug registers. This debug registers allow 80386 processor to provide the debugging feature. Now you all know what is debugging, right? It is the process of identifying and removing the errors or bugs from the software or hardware. For that purpose, we are using debug registers. Now to control the debug features, there are 8 registers from DR0 to DR7. Here is the diagram for debug registers. DR0 to DR3. These debug registers provide the breakpoints in the linear addresses. Now, what is it exactly? We will see one by one. Now looking at the debug registers 0 through 3. The first, it means this first 4 debug registers contain 32-bit linear breakpoint addresses. Now what is this breakpoint addresses? In general, the breakpoints are inserted into the program or into the instruction to identify the errors, right? These breakpoints addresses which may locate in an instructions and constantly compared with the addresses generated by the program. If this match found or match occurs, the 80386 will cause a type 1 interrupt. If directed by the debug registers DR6 and DR7. Now, as I told you, these breakpoint addresses are very useful in debugging a faulty software. Means they are useful to find out the errors in the program, to find out the faults in the software. Next registers are debug registers DR4 and DR5. These two debug registers are reserved by the Intel processor. Further, we are having debug register 6, that is DR6. This DR6 is also called as debug status register. If this bit is set, it indicates the condition that may have caused the last debug fault, right? If this bit is set, it indicates the last debug fault. These bits are generally never cleared by the processor. User has to clear this bit manually by writing into the status register. The control bits in DR6 and DR7 are, you can see the diagram, the control bits of DR6 and DR7 from B3 to B0. These are the control bits of your DR6 register. B3 to B0, they indicates which of the 4 debug breakpoint addresses caused the debug interrupt. For example, if B0 bit is set, it refers to the linear address contained in your DR0. Just now we have seen the linear address contained in your DR0 to DR3. If this B0 bit is set by the processor, it refers to the linear address of your DR0 debug register and modify the condition set by the len 0, read write 0, L0, G0, LE, GE fields in DR7 registers. Here we can see those of fields. Now next bit is your BD, break for debug register access. This BD bit is break for debug register access. If this bit is set, it indicates that the debug interrupt was caused by an attempt to read the debug register with the GD bit set. Now this GD bit of DR7 protects access to the debug register. What is the function of this GD bit? We can see this GD bit in the DR7. This bit protects the access to the debug register. Now next bit is BS, that is break for single step. As we know, single step means there is a trap flag for the single step interrupt. If this BS bit is set, it indicates that the debug interrupt was caused by the TF bit in the flag register. Remember, trap flag bit in the flag register. It indicates the break for single step. Now, this BT is the break for task switch. Now, task switch is switching in between the task. If this BT bit is set, it shows that the debug interrupt was caused by a task switch. Very simple. Debug interrupt caused by the task switch. Break for the task switch. There is an interrupt for the task switch. Now, next debug register is your DR7. This DR7 allows us to control the operation of 4 linear address breakpoints, that is from DR0 to DR3. This can be done with the help of programming only. Each breakpoint can be controlled by a set of 4 fields. Each breakpoint can be controlled by the 4 fields in the DR7 that we'll see one by one. First one is your line 3 to line 0. In the diagram, we can see line 3 to line 0. Now, what is it exactly? This is breakpoint length. It shows the breakpoint length. Each of these 4 length fields are related to each of 4 breakpoint addresses stored in the DR3 to DR0. Yes, linear breakpoint addresses are stored into the DR0 to DR3. The length of that breakpoint is shown by line 0 to line 3 fields. Now, these bits are also defined the size of axis of the breakpoint. It shows the size of axis of the breakpoint. Now, here we are having the table which shows the sizes of the breakpoint. Now, here is the length and length bits in the DR7. When length is 00, it means the bits of length, size of the length is 1 byte. When it is 01, the size is 1 word. For 10, it is reserved, and for 11, it is 1 double word. Now, next field is read write 3 to read write 0. Again, we can refer the DR7 diagram. DR7, the bits from read write 0 to read write 3. Each of these 4 read write fields related to each of the 4 breakpoint addresses stored in the DR3 or DR7, right? It is again related to your DR0 and DR0 to DR3 registers. Read write field selects cause a list of different access types. We are having table for these different access types. Suppose read write bit is 00, then read write bit in DR0. It shows for the 00 it shows the instruction access. For 01, the data write operation can be performed. For 10, it is reserved, and for 11, data read or write can be performed. The next bit of your DR7 is GD, that is global debug access bit. When this bit is set, this prevents any read write operation of a debug register by generating a debug interrupt. As we have seen, this GD bit of DR7 protects the access to the debug registers. This bit is automatically cleared during the debug interrupt. That's why debug registers can be read or changed if required. This is all about your GD bit. Now next bit is GE, that is global exact bit. If this GE bit set, then 80386 selects a global breakpoint address for any of the 4 breakpoint address registers from DR0 to DR3. And the last bit of your DR7 is LE bit, that is local exact bit. If this LE bit is set, it selects a local breakpoint address for any of the 4 breakpoint address registers. Now breakpoint address register, address register, it all about DR0 to DR3, because this DR0 to DR3 debug registers provide the linear breakpoint addresses. Here we have studied the debug registers and the function of every bit of the debug register. Now moving forward, the debug exceptions. Now you all must be clear about the interrupt and the exceptions. Those exceptions and interrupts are the asynchronous or synchronous external events that hold or halts the normal functioning of the processor and tells the processor the phrase, remember, serve me first. Now this debug exception, in that we are having the topic single step interrupt. This single step interrupt mode, the system will execute one instruction only and wait for the user. Single step interrupt, system will execute only one instruction and will wait for the user for the further action. The user can observe the contents of register memory locations. If they are correct, then user can proceed with the next instruction. This is your single step interrupt. When this is caused, it executes only one instruction waiting for the further action of your user. This is a trap. Single step means always it is related about the trap flag or trap. This is a trap debug exception. This exception occurs if the trap flag is set. Single step interrupt is all about the trap flag. Remember, trap flag for the single step interrupt. When it occurs, then trap flag will be set. This 80386 processor does not have any instruction to set or reset the trap flag. There is no instruction to set or reset the trap flag. But when this trap flag is set, the single step type of interrupt occurs, then only the trap flag set. Otherwise, there is no instruction to set or reset the trap flag. Moving to the last point of this video, breakpoint exception. Now what is breakpoint? Just now I have told you the breakpoint exception, you all know. Now breakpoint interrupt. This int3 is a special software interrupt designed to be a breakpoint. Now what is breakpoint? We are inserting the breakpoint in the program to get the errors or to catch the errors. Now int3 is a special software interrupt to design for the breakpoint. The difference between this int3 and other interrupts is that the interrupt 3 is 1 byte instruction, whereas other interrupts are 2 byte instructions. This function is used as a debugging help in cases where single stepping provides more details than wanted. Single step interrupt, it is caused by a trap flag. Trap flag is set when the single step interrupt occurred. The user can insert the number of breakpoints he wishes. Why we insert the breakpoints? Just now I have said why we insert the breakpoints: to catch the errors in the program. For inserting the breakpoints, we are having this interrupt 3. It helps to insert the breakpoint in the program. This is all about breakpoint exceptions. Thank you.